Hello guys, good evening.
Good evening, sir.
Yeah. Yeah, because are you fine now?
Yes, sir.
Yeah. Did you watch the video last class?
Yes, sir, I did.
Okay, because we'll continue from that only. Okay. So guys, last class we started chemical kinetics and we discussed about the rate of a reaction. Correct? How do we define a rate? So I'll do a quick recap. Okay, the rate expression, and then we'll see some problems. Okay. So let me see who all have joined. Okay. Just we'll wait for 2 moments. One minute, give me. Yeah. So, okay, so last class we discussed about the rate of a reaction. And suppose if you have a reaction given like this, the rate expression would be what? Suppose for a reaction, if I write down 2A gives 3 times B, okay? So at time t is equals to 0, its concentration, suppose I am assuming A naught, this is 0, and at time t is equals to t, A converts into B, so it is A naught minus 2x, and this becomes 3x. Okay. The rate of A is nothing but the rate of disappearance of A or rate of consumption of A, right? Rate of A, I said, rate of A, or we can also write rate of reactant. That is nothing but rate of consumption, and that is nothing but the rate of what we can say disappearance. All these things are same. So anything you may have in the test, right, in the exam, all terms are same. This is equals to minus of d by dt of concentration of A, instantaneous rate, negative. For reactant, we always take the negative sign, which the expression becomes minus d of dt. That is final minus initial a naught minus 2x minus a naught. And when you solve this, you'll get minus of, 2 dx by dt. Minus dA by dt is equals to 2 dx by dt we get. Okay. Similarly, we had also discussed the rate of B, which is nothing but the just opposite of it, rate of product, rate of appearance, and rate of production. All are same thing, is equals to plus d by dt of concentration of B, which is equals to plus d by dt of final minus initial, which is nothing but 3 dx by dt. So if you look at this expression, and this one, and this one. So if I equate dx by dt from these two expressions, we'll get dx by dt per mole is equals to minus of 1 by 2, or minus we'll write down like this, half the negative of d concentration of A by dt. This negative of d concentration A by dt is the rate of disappearance of A, includes the negative sign, is equals to 1 by 3 plus d of concentration of B by dt. So this is what this dx by dt is, the ROR, that is rate of reaction. We discussed last class, right? And dA by dt is this. Rate of disappearance is always rate of A. The expression you see, I am writing it down minus dA by dt. Okay? And rate of B is production of B plus D concentration of B by dt. This is the two things you must take care of. Okay. So last class we discussed till here. Okay. It was just a quick recap. Okay.
But you told us to remind you that there's one question we had to do.
Yeah. I'm coming to that. Maybe some of you were absent last class, so that's why I've just given a quick recap of it. Okay. I'm coming to that question only. Before that, just one general expression I'll write down. Suppose we have a reaction. You have those who were there in the last class. You have already written it. Just let it be. Okay. AABB CC plus DD we have. Then the rate of reaction for this reaction, the general expression we can write dx by dt is equals to 1 by A minus of d concentration of A by dt is equals to 1 by B minus d concentration of B by dt, and then 1 by C minus concentration of C divided by, it is minus or plus C by dt equals to 1 by D plus d concentration of D by dt. One last thing, that in this chapter, whenever I write this A in this square bracket, the square bracket means the concentration of A. So this term itself means the concentration of A we are talking about. Okay. So this is what we were talking, we had talked last class till here. Now you see a few questions on this. The question is, we have a reaction, say 2A plus 3B gives 5C. Okay. At time t is equals to 0, it is given A is 10 molar. Okay. And at time t is equals to 20, any unit, second you can say or anything, this becomes 5 molar, right? You need to find out the rate of A, the rate of B and rate of B, then rate of C, and the rate of reaction. Try this. The simplest one, right? Done. Yeah. So the rate of RA is equals to, and it is the average rate basically, right? So it is negative of final minus initial divided by the time taken for this. And that is 1 by 4 molar per second. Suppose the time is given in second here. Okay. Similarly, we can write for this reaction ROR is equals to 1 by 2 minus of dA by dt. This expression we can write is equals to 1 by 3 minus of d concentration of d by dt. And then we have 1 by 5 plus of d concentration of c by dt. Okay, so minus dA by dt is given 1 by 4. Right. Minus dA by dt is rate of this. Okay, fine. So rate of A is equals to what we can write? Rate of A is minus dA by dt. Okay. So if I substitute this here, we can find out the rate of reaction one by one. One by one, we can find out all these things. The rate of reaction would be 1 by 4 into 1 by 2, that is 1 by 8 molar per second. The rate of B, RB is equals to minus dB by dt, right? So RB is equals to 3 into 1 by 8, that is 3 by 8 molar per second. And RC is equals to 5 by 8 molar per second. Simplest one, right? Okay, this was the basic question we have. So if you know the data for one reactant, you can find out for that. And then with this relation, we can find out the rate of the other species, other reactant or product that you have. This question you see. The statement is for the formation of NH3 from N2 and H2. Formation of NH3 from N2 and H2. The rate of N2 is given, that is 1.5 into 10 to the power minus 3 molar per second. This is given. You need to find out the rate of reaction. Okay, the options are 1.5 into 10 to the power minus 3 molar per second, 3 into 10 to the power minus 3 molar per second. C is 0.75 into 10 to the power minus 3 molar per second. And D is, I'll take one, can't determine. Chalo. That we don't know, Vikas. Okay, that we don't know. Okay. Now you see, I'll solve this. This is a very good question. Okay. Now you solve this. I'll do this just you see. Okay. What is the reaction we should write here?
N2 plus 3H2.
N2 plus 3H2 gives 2NH3. So we can write a rate of N2 is equals to what we can write? 1 by 3 of rate of H2, can we write this? Is equals to 1 by 2 of rate of NH3. Right? And this is equals to what? The rate of reaction. The ROR. Is it correct? Rn2 is given. So rate of reaction directly you can equate and you will get 1.5 into 10 to the power minus 3 molar per second. Okay. This is the one thing that you can do. Now, suppose what I am doing, I am taking this half of N2 plus 3 by 2 of H2 gives NH3. Suppose this reaction is there. So if I write down the expression will be 2 times of R of N2. Correct me if I'm wrong. Okay, the calculation mistake if it is there. This would be what? 2 by 3 of R of H2 is equals to R of NH3 equals to ROR. Isn't it correct? Can we say this? Right?
Yeah.
So what is the rate of reaction from this? That is 2 times into R of N2 and we are getting 3 into 10 to the power minus 3 molar per second. Okay.
So the rate is always defined for 1 mole. So we have to take 1 mole of N2.
No, that is what I'm talking about. Just listen to me first. Wait, 2 minutes. Okay, see the question, this question, first of all, it was asked, the exact question was asked in JEE. And what mistake you have made here, the same mistake has been made by most of the students. Okay, and you see how they frame the question. It's very simple reaction, right? Everyone knows this reaction, right? Even a 10th grade student, if you ask that what is this reaction, they can write you this N2 plus H2 gives 2NH3. So they have taken a very simple reaction so that you can directly write down this reaction and find out the answer with respect to this reaction. Now suppose Ruchir has written this reaction in the test paper. Ruchir has got this answer. He goes with option A. He was like, okay, this is the correct. Right? But Pradyut has taken this reaction. He got this answer. He goes with B. And now he is saying, okay, B is correct. But we cannot have both answers, no? Are you getting my point? The question for a given set of data will have only one answer, no? Right? So the trick here is what? That the first step that you have taken, the mistake that you made is you have assumed the reaction. The reaction is not given in the question. If the reaction is this given in the question, answer is this. If the reaction is this given in the question, answer is this. If you take any other reaction with any other stoichiometric coefficient, answer will be something else. Okay, so we can have n number of answers here depending upon what reaction you choose in the question. Are you getting my point?
So the answer here
Yes.
can't be determined.
Yes, for this question, the answer is this is not correct, this is not correct. The answer is this, cannot determine. Why? Because the reaction is not given in the question. It is the other matter that you know the reaction. Once you write the reaction like this, You have assumed the stoichiometric coefficient that you cannot do. Are you getting it?
Yes.
Because clear?
Yes, sir.
Right? So please take care of these things. Very simple question. And 99% of the students, they have gone wrong in this. Right? So you cannot miss out this kind of question. Please take care of this. Even if you take the another stoichiometric coefficient you take, you'll get option C also. That is also possible. Right? So for this question, the answer is what? The answer is cannot be determined. So what is here, like last class also I said that the reaction, see, I'll go back again. Just let me just go back. Here you see what I have written. You must be wondering that why I'm writing this thing again and again, because I have done this last class also. I have written the rate of A is simple minus dA by dt. Do we have any stoichiometric coefficient here? Is it? No. So to find out the rate of any individual species means any reactant or product, you just need the concentration at two different times. That is it. इसको subtract कर दो concentration को, divide by the time required for this change. वो उसका rate हो गया. Are you getting it? So rate of individual species is independent of the stoichiometric coefficient you are taking in the reaction. But अगर हमें rate find out करना है, if you need to find out the rate of the reaction, we need this A, B, and C. It should be given in the question. अगर reaction नहीं दिया है, you cannot find out the rate of the reaction. Yes, clear?
Yes, sir.
Correct. So in this question, you see, even you can cross check whatever I said just now. You can cross check here. If the question is find out the rate of H2 or rate of NH3, then whatever reaction you take, the answer will be same. If you take this reaction, you can find out the rate of H2 or rate of NH3, and the rate of H2 you will have here, the same rate you will get here also. You can try. Find out the rate of H2 in both reactions. Could you do that once? Done? Is it same you're getting in both the reactions?
Yes, sir.
Right. So always keep this in mind that you can not find out the rate of a reaction which is not given in the question. Right? You cannot assume the reaction. So write on one note after this. Write down if the balanced reaction A relative rate we can say, because in real life situation you're talking about, so relative rate we can take. Okay, so a relative, it is reacting in this rate, N2, H2 and R2. The rate of the reaction we cannot say in that case also.
Okay, sir.
Right? We can say it will be either in a multiple of this thing. In that way you can say. Okay, so one note you write down here, if balanced chemical reaction is not given, if balanced chemical reaction is not given, then we cannot find out the rate of reaction. Then we cannot find out the rate of the reaction, since the rate of reaction, depends upon, depends upon the stoichiometric coefficient. So the rate of the reaction depends upon a stoichiometric coefficient. So what reaction you have taken, what stoichiometric coefficient you are taking, it depends upon that. According to that, you'll get the rate of the reaction. Next line. But the rate of any individual species, we can determine rate of any individual species, we can determine without knowing the reaction, it just require the concentration or pressure at two different time. Concentration or pressure at two different time. Okay, so must take care of this. This exact question was asked in JE. Okay.
Could you repeat that previous sentence?
Which one? Last point.
Yes.
The last point was, I'll repeat this. But the rate of any individual species, we can determine without knowing the rate of the reaction. And we just need the concentration or pressure at two different time for this. Concentration or pressure at two different time. Okay, this is very important thing. Now, one more question you see. The reaction is given, that is N2 plus 3H2 gives 2NH3. If the rate of ammonia is 1.7 kg per hour for the given reaction, then calculate the rate of hydrogen, rate of H2 in gram per minute. Okay, how many of you are getting 42.5 gram per minute? One, two, three, four. Okay, so it's just most of you have got 42.5, correct. How many of you have got 5 gram per minute? Okay. What is your answer here? Okay, Mahit, you got 42.5. Okay, so these two options were there in the question. The same question was asked in JE. Okay, and the correct answer in this is 5 gram per minute. 42.5, most of you have got, and in the exam also, most of the students have got 42.5, but that is also again wrong. Why? I'll tell you. What you have done, rate of ammonia is given, right? So R of NH3 equals to 1.7 kg per hour. And with respect to this, if you find out the rate of H2, that would be what? 1 by 3. It is 2 by 3 times of, sorry, it is 3 by 2 times of 1.7 kg per hour, which you can change the unit
2.5. Wait.
1.7 into 1000 divided by 60. And when you solve this, you'll get 42.5 gram per minute.
But you have to convert it to moles and
Yes.
oh, come.
So this is what you have done. Most of you have done this. In the exam also, they have done like this only. But the point is, this 3 by 2 is the molar ratio, isn't it? Yes. And this is the mass given. So you cannot relate mass and moles. So here your answer was right. The first answer that you gave. Okay. Roger Parekh, yes, you also got it right. Yeah. So this is moles and this is mass. So you cannot do this. The entire thing is wrong. So what you need to do, you need to convert this kg per hour into mole per minute, right? So you can keep this in mind that rate of reaction or rate of any individual species, you must have to take in mole per time. Time unit can be anything, hour, minute, second, depending upon the what data is given in the question, right? But the numerator here, it must be moles. You cannot have mass in the numerator. So convert this into moles, right? Convert this unit into this entire thing into mole per minute, and then you can relate with this. Tell me what you're getting. Yeah, correct. Yeah. Okay, so all of you must take care of all these things. Okay, this chapter is quite easy, right? The solution, solid state, chemical kinetics, electrochemistry, a little bit tricky, it may have some time. But these three chapters, directly you will get 4 marks, right? So 4 into 3, 12 marks, you should not miss. Only thing is, just small things you have to take care of. This chapter is quite mathematical, okay? There's nothing like exceptions kind of thing. Like obviously we have chemistry, so 2-3 things hardly you have to memorize here. But everything is quite, it's very mathematical. Once you know the concept, you can do it easily, but don't do mistakes like this, okay? Remember that. The exact question you see, it was asked in JEE. So in JEE, they have asked this kind of question where you can make mistakes because they always reject the students. It's all about rejection, okay? because to select 50,000 out of 15 lakh is very difficult, right? Rather than the rejection thing. To take care of all these things. Okay, both questions were asked in JEE. Okay, one more simple example, simple question we'll see, and then we'll move on to the next topic.
Wait, so how do you like convert it into moles per minute again?
See, I'll do that. Wait. What is given? Rate is equals to 1.7 kg, right? So first of all, we convert this into grams. So 1.7 into 1000, it is gram. Mass divided by molecular mass. Molecular mass of what? This 1.7 is given for NH3, ammonia. So molecular mass of ammonia, 17. So this becomes mole, right? Mole. In the denominator, we have R. We have to convert this into minute, then into 60 here. So this becomes mole per minute. So first kg to gram, then gram divided by the molecular mass gives you the number of moles and the unit conversion of time. Understood, Mehul?
Yes, sir.
Right, so this you'll get rate in mole per minute. This you multiply by 3/2, you'll get the answer. Okay. This question you see, A gives B and it is an unbalanced reaction. We don't know what is the balanced reaction we have. The reaction is unbalanced here. And the relation it is given, it is log of minus D concentration of A by dt is equals to log of plus dB concentration of B by dt plus 1. This relation is given in the question. Find out the molar ratio of A and B.
So log is natural log, right?
Sorry?
So here log is natural log, right?
Yes, base 10 we have here.
Oh, base 10.
Find out the molar ratio of A and B. Yes, 10:1. Simple mathematics you have to use. 10A gives B. So we can write this as log of base 10 minus dA by dt is equals to log of base 10 plus dB by dt, and one we can write log 10. Okay, so this is equals to minus dA by dt is equals to 10 plus dB by dt, which further we can write 1 by 10 minus of dA by dt is equals to plus dB by dt. So this becomes the stoichiometry coefficient. So reaction is 10A gives B. So ratio is 10:1.